I think it is safe to say that when it comes to small game production, Godot is already a common choice, especially if it comes to game jam games. But what about larger scale productions? Can Godot handle it already? Well, the team at Epic Tellers is currently working on Starfinder, a full-scale RPG made in Godot with a team of 30 developers. How good does it work? What challenges arise? Well, I think there's no one better than the team of Epic Teller themselves. Please give a round of applause for Maria, Rick, and Felix.
Hello. We did this presentation in like a week because we are very busy, so sorry if it's a bit sloppy. Just to start, so presenting myself, I'm the co-founder of Epic Tellers, and I also work on coding when I have some time. Then with me is Felix, who will talk about narrative, and then Maria, who is our awesome level designer. So a bit of us before we move forward to understand the context. That was us last year at GodotCon, talking about a demo that we did for CRPG, trying to make a CRPG with Godot. It went very well. I mean, this was built in 6 months by 8 people. We saw the potential. We used that to pitch and try to look for even a bigger project. Back then, that was the team that did it. Half of them already sitting here. But nowadays, we really look more like that. So how is this going? First, to align ourselves, in case I'm sure that, we just announced it 2 months ago. So in case, just to understand a bit of the game, that's the trailer.
All Kasafa staff at the celebration. The Coolin's missing. You were right. No better day to break into the vault of memories.
I just hope no one misses those raw-sucking ratas for a while. No offense. Can you make haste with that lock? Or is that fluffy brain's reputation of yours just for show? I've seen the end of light. The cold night engulfing us all. We are all dancing on the plank's end because nobody believes me. Because it has not happened yet. You won't let it happen. Help is on the way. From the one looking for his courage, to the one who needs to believe in himself. From the one dreaming of freedom, to the one who needs to face the truth. From the family you didn't know you needed. Get ready to run. Get ready to strike, to loot, to love hard, to fight, to burn the galaxy. We are sailing the last tide. Come find me!
Thanks. So we just finished the Kickstarter last week. It went very well. So there is attention for there is enough, let's say, visibility into the game. But now we need to actually get it done, and CRPGs are really complex. So the problem that we faced structurally was that when we did Forbidden Lands, we were 8 people. So we rushed to it. As René was saying, speed is everything when you are doing that. So what you do is that coders are happy to work with Godot. They work very fast. So writers for narrative, they just send the stuff to coders, and coders make it happen. Same goes for artists, for designers, for audio. And probably you are seeing what happens, right? So coders stop being productive. They start hating each other. They start talking bad about the other disciplines. They don't know how to do it, and that's really not working. So we first needed to untangle that. This is what we really want, and how we achieve that. So the first problem is looking to the writers. How we make the writers work directly with Godot without anybody in the middle. For that, we built a tool called Loom that we will talk more about it later, but basically is the common thing of just branching narrative tool with Godot. For designers, we actually extended Loom and made some high-level logic work also inside the Godot itself, so they don't need to hassle programmers. They still hassle programmers, but way less. For artists, well, it turns out actually Godot 4 is evolving pretty fast. So our pipeline is, most of it is around Blender. And the pipeline from Blender to Godot, it needed some work, but it doesn't need a lot of new stuff, things that were not there. Already, most of the artists, especially technical artists, open Godot frequently and do things directly there. For example, most of the artists, I think they built all the materials already in Godot, if I remember correctly, right? Yeah. For audio, well, Duba, our audio guy, we actually searched for the solutions for audio, and we decided to not take FMOD or WISE or something else more complex. We feel that with Godot features, we can already do what we want. So one of the things is that for sound effects, what we do is that we build a code about detecting files. So I tell Duba, hey, if you want this character to say something when they cast this spell, drop that file here. He already knows how to make the resources for randomized sounds and everything. He just put them there with the right name, in the right folder, and it will work. And if it doesn't, he will hassle me, but that's okay. And then he already directly worked with interactive music and music that opens and closes different channels, which is the new things from Godot, which I think with this is way enough to do a pretty good audio for the game. So result, great. Now we could scale from 7 to 30. Everybody's working in Godot. And that created another problem, is that now not the coders are crazy, Godot is going nuts because, and that's not really Godot, it's the repository. The build was broken quite often. I mean, we more or less took care of it, but there was so much stuff happening in the same day, in the same repository, that was difficult to keep stability and to keep everything in check. So my first approach, I think is the approach that I've taken in most AAA, is threaten them, okay? So if you break the build, there will be consequences. That works a bit. I mean, I have to say, violence sometimes is the answer, but it doesn't work very well when you find yourself breaking the build. Sometimes they were looking, yeah, but Rick, it was you. Nah, impossible. Well, it was, because it's just the build is growing, or the project is growing so complex, with so many people putting in things there, that it's very easy to break it, even if you know what you're doing, even if you are careful. So it's clear that we needed to come up with something even more complex than that. Last year, we already talked about our pipeline for for continuous integration. What we did is even expand it more. I mean, that could be a full presentation here, but I just want to say that very few simple things come a long way to stabilize things. This one, for example, checks if files are too small or too big. That was a reaction of an artist adding 170 megabytes into the build, and it was like, what the fuck is this? This should never happen again. So we just checked for extensions, and we said this is the maximum and the minimum, because sometimes you think you have a PNG that is fine, but it's like 0.1 or 1 kilobyte or something. That must be something wrong. So you can already detect some stuff here. You can do that with meshes, too many triangles, too less, unbroken meshes, things like this. You can check for reference. We open every resource in text. We look for all the UIDs, and we check if that file actually exists. And if it doesn't, the pipeline will stop the build. You know what I'm talking about, most likely. Broken reference is one thing that it's very easy to break. Textures, that they need to be in the right format, in the right folder. We even open every level in the pipeline and make sure it loads in less than 15 seconds. And if not, we stop you there. We even open the game and go through the menu automatically, the main menu, and then open the first level and check if there are memory leaks, there are warnings, there are anything. For example, this one, I'm very fan of this one, even if the rest of the team hates it, which is, and they know it, which is probably very self-explanatory. Every file is checked against this, those searches. If you add a file in the file system that does not meet any of these criteria, you don't pass the pipeline, you cannot merge to main. This allows that very well-structured file and folder, and this comes from the old AAA tricks that we did in big companies that we need to keep everything sane. This made actually another problem. Everything was very strict, and sometimes you just want to open the build and try things. You just want to, I don't know, see how something could work. So what we did is we created the gyms folder where everybody creates a folder with their own name, and they just go there, they can go crazy. Pipeline doesn't care what you add there. But the moment you move those things that you feel are good outside gyms, then the pipeline will check everything. As an example of what happens when we upload a build, we triggered workers through our GitLab process that this is, for example, one of the tests of the feature test where, I mean, it's working very fast because we actually make the timer of Godot go faster to speed that up. But it's starting the save test, goes to save point, saves the game, go and finish it, and then loads the game and make sure that you can move and go to the other side. Here we are indirectly testing 10 to 15 systems, not including save, but you can move, the animations are there, the character exists, the load, the level, and so on. If anything that you do breaks this, you won't be able to check into main. Last tips that I wish I knew 1 year ago. First, we took a decision when Starfinder is that Godot is so small, really small, that when we compile our version, and I have to say we don't do much on C++, we basically take most of vanilla Godot, we put the binaries into the repository, which is counterintuitive. You don't want binaries in a repository. Actually makes a lot of sense, because when we upgrade from Godot 4.4, for example, 4.5, it took 1 day. And then on Monday, people just loads, and the binary and the data is always in sync. You don't have to tell people you need to download a new version and things like this. Also, having Godot in the binary allows Godot itself, all the pipeline, everything that you guys saw of checking meshes, and everything is doing Godot, coded in Godot itself. So the whole repository is self-contained. You can download it anywhere, and it will run, and all the pipeline can be executed in local, because Godot runs the pipeline itself. We used to do that with Python. We removed Python out of the equation, and Godot, honestly, is really very easy to work with. So it's a very good substitute for Python. Other thing that it's extremely simple, and I was a bit embarrassed to say that because maybe everybody tells me, Rick, we do that. It was you that you dropped the ball here. We don't think of scenes as levels all the time. We don't think even of scenes as a way of building characters, which we do, of course. So we think of scenes as just data in a tree. And there is a lot of data that makes sense to make it in a tree. And this, for example, is our level manager that identifies which scenes are actually levels in the game. And it makes sense that it is a tree. So the game, it has an Act 1, it has different locations, and inside it has levels. So we represent this information in a scene. This scene is not related to anything about a level, but it structures the information very well. You have a very powerful tree editor in Godot itself. Use it for anything that could be represented as a tree. for example, quests are built all in a tree. This is not using much of the tree functionality, but those are the game states. And instead of having a folder with tons of files that are organized in some specific, I don't know, whatever folders are organized into, what we have here is that those are the game states. And when I need a game state, I know I open this scene, and then I check for the game state visually. I can navigate the functionality very fast. For example, we have a scene that describes the whole systems of the camera. I just open there, and I can see all the 20 bits and functions that are the camera, but this is described in the scene because it's just really a very powerful tree editor. And I think that's it. We'll go to Felix.
Perfect. Thanks, Rick. Well, hello, my name is Felix, and I'm a narrative designer at Epic Tellers, and of course, I'm here to tell you a story. And it's the story of how we went on a quest in the far land of Hispania, looking for our narrative tool to fulfill all the long wish list that the narrative designers at Epic Tellers began to build. And this started in that game that Rick was telling you about, the game we show at Godot. During this, we learned a lot. We learned that writing for CRPGs is really complex. You have a lot of variables. Did you fight with a faction? Did you become friends with them? Did you betray the old lady in the square, in the main square? Everything amounts to changes in branching narrative. As you know, this can quickly become very complex and very ugly real fast. And we realized that with our friend, the spreadsheet. You know, spreadsheets is the go-to solution for games, and for most games, it works. And for us, it worked for a while, and it did a good job. Thanks, chums. Our friend chums know the story. But very soon, there is so much that there is not much that a single row of a spreadsheet can contain. So somewhere in that process, we realized we need something else for our real game. So it was okay, but we had a long wish list. So we went there on this quest to find our weapon against this complexity. And of course, we went to the usual suspects. We asked, what are the industry standards to work? Of course, RTC, for example, is like, you have RTC, everything you need is there. It's big, it's complex, you have support, you have integration. At the time, the integration with Godot was not a sure thing, but we are working on it. Of course, Godot is in the horizon, so there's that. And some new actors like Arcwave offer online solutions, web solutions, and then they were very enticing. They were like, come here. And it was nice. We really liked them. So we were, after 6 months of trying, testing, we were almost on the verge of a decision. And RTC was like kind of convincing. But the thing that worried us the most was integration and sync. Like our main goal in narrative for this project is fast iteration. We wanted to test things fast, correct, test again, and we were worried that this process of integration would consume a lot of our time, and we had to deal with integration problems and support. So when 6 months have passed, Rick told me, I remember clearly, he told me, Felix, give me the weekend. I want to try something in Godot. And that was the beginning of, this was Rick and I talking about it. And after that, very moving hug, he told me this. And the solution is what we now know as Loom, the system that Rick was telling you about, okay? And I'm gonna show you how cool is working with this tool that we developed, and I say we developed, writers we do that, appropriating the success of others. But the thing is, I'm going to show you how cool, how is a normal day working with this tool and what are the benefits of that process. And I'm going to do that asking for the help of one of the companions in our game. This is Android Lu 323, and she's one of the main companions of the game. And I'm going to show you a typical example of how we come to a level and start working on dialogues. When we come, Maria is going to tell you about it, but when we come to work, we already have like a skeleton of the level that we are going to work in. And we just get there in Godot, and we start creating dialogues. In this case, we're going to create a dialogue for Lu 323 in an event called Cos Cauldron. That's the name of a bar in our game. So I just create a Loom file. A Loom file is just a text file. So it's easy to do code to work with Git, and doing merges, resolving conflicts is easier. And every Loom file, every dialogue, every narrative interaction starts with a Loom file and an entry point. This is kind of the universal identifier in Godot. So anytime we want in Godot to tell the system, okay, clicking on this NPC is gonna start the dialogue. We do that by telling Godot, okay, this is the Loom file, and this inside that Loom file, you're gonna use that entry point. So it's very easy to have a Loom file with multiple entry points. So in this case, for example, you can start the dialogue with this companion from in several different ways, each one of them with a different entry point. And it's very easy for us writers to visualize what the interaction is about, if it's a complex flow, if it's chaotic. If you see here, connections, like chaotic connections, you don't have to dig deeper, and you can easily realize, no, this dialogue is kind of messy. So you can see like complex flows and see if the pacing of the dialogue looks okay, just from looking at it, okay? And another benefit of this, of Loom, is that every time we want to use or make reference to an element inside the game, inside Godot, is as easy as locating the element on Godot and dragging and dropping. For example, I want to specify that this speech dialogue is Lu speaking. It's as easy as going to our census. Census is basically the definition of a companion with all their skills, with their picture, the name, and just dragging and dropping. And the same with every element, like gamer tags, quests, whatever. It's as easy as dragging and dropping, okay? And the cool, this cool graphic you are seeing there is a typical example of how Loom, or how the narrative team interacts with other subsystems of the game. We have created, the devs have created custom nodes, specialized nodes that interact with subsystems. For example, we see there, we have your typical branching narrative. You are going to offer the player choices, but those choices are conditioned by some events. For example, here you see we have some special condition nodes. One of them asks if that book that character with a book appearance is on our party. If that is so, we can provide the user with a specific option. The same with inventory items. Do we have this item in our inventory? Okay, offer the player this choice. We have nodes for doing skill rolls. What would be of an CRPG without throwing dice? For example, this is a node that allows us to specify which of the characters is doing the skill check, what is the attribute we are testing, the difficulty, and all the possible outcomes. Critical success, success, fail, critical fail. It's very easy to create these branchings on Loom. And of course, for example, gamer tags, the game tags. The game tags are the persistent global scope variables that we use to define the progress in the game. So it's easy for us at any time to set game tags or check game tags. And this is so quick, so fast for us and so simple that our team, people that don't have any experience at coding can easily build complex logics and start prototyping dialogue and interactions in minutes. So it has proved, it has been very important for our goal of fast iteration. And when we are working with that and talking about fast iteration, the fact that we can play the game, we can test the game, and we can see in real time the flow moving, we can see the flow advancing, we can check whatever the exact path we are taking, and we can change in real time the content of the nodes, change the options, change the skill roles, and we don't have to restart the game at all. We just go and talk to the same character again, and the changes are reflected. So it's perfect for our, we have sessions of peer-to-peer play testing in the narrative team, so we can see things, no, I don't like this, let's try if this sounds better. We can test, and the changes are already there, where we just have to commit the change, and it's as easy as that. Of course, we have more tools that I could be showing you characteristics of Loom, but for example, we have stats. We have, our game is gonna be voiced by actors like most of the dialogue, so we need to keep in check, for example, how many lines of dialogue, how many words each one of the character has, because we have to schedule and plan the voice acting recording sessions. So we have this, we can keep track of which character is becoming expensive, so we can kill it, so we can kill them. So that's mostly the decision comes from this. And of course, we can check all the pipeline errors ahead of time, and we can run this validator, and we can double-click each error and takes us to the exact node, so we can take action and correct it. And it's very, very easy, and it's very fast. But the most beneficial, I think, feature of Loom is how we can integrate with level design, with Maria, for example. When I work with Maria, it's very normal that we are working on different flows. We are working in our dialogue flow, the narrative flow, and she's working on the more logical flow of the level. And sometimes, and most of the times, we interact. For example, in this case, it's the typical dialogue where I know that after talking to Lou, the level is going to do something awesome. The character and the party, they are going to try to break a crate. I don't know how she's going to do that. I only know that they are going to try that. So I can call another Loom file and a specific entry point, and I can expect results from that call. And I just need to know if they succeeded at breaking the crate or if they failed. And I can resume the dialogue flow accordingly very easily. She can be working on that, I can be working on this, and we don't have any conflicts. We can work in parallel. She can have a stop, meanwhile, and put something temporarily. I can put temporary dialogues, and it's very easy. We don't have any kind of conflicts, and we can work in parallel. No one has to wait for, and this jump is not only useful, jumping between files, but it's the typical go-to, and I can make modular dialogue easier. And the next logical question is, compared to the original six months of scouting and testing software, how many months did it take Rick, because Rick is the father of Loom, how many months did it take Rick to develop Loom to this level that we are currently using? Exactly 2 months. So if we compare that to the time that we spent trying software, if we had done this, we would have saved 4 months. But the message here is that you don't have to be afraid of trying to use Godot to fulfill the needs, in this case of narrative design, because it's very easy, and the results, as you can see, are for us, in part of what we wanted to use from RTC and ArcWeave. We are fulfilling our full wish list of features, and it has been a really, really fast process. And with that, let's use Loom to jump to Maria. Maria.
Is this working? Yes. Thanks, Felix, for the introduction. I'm Maria, and I'm a level designer in Epic Tellers, and I'm going to be talking about this subject from the perspective of our department. If you've ever worked in video games, you may have seen that a level is a place where everything comes together. So every department is going to throw their things and their work on it, like gameplay, logic, the systems, the art, the dialogues. And everything is going to come together, and you're just going to watch it and hope that it doesn't explode. The bigger the team, the bigger the explosion. So I'm going to go over some of the ways that we have been using Godot to bypass these danger points. This is the workflow that we use in Level. I'm not going to go over it because we're not innovating here. You can watch GDC talks about this topic whenever you want. The important part is that we are constantly communicating with our departments, and we are constantly working very closely with all of them. So that's why I'll be pinpointing some of the things that we've used to go over this smoothly. So one of the important steps is the blockout. This is the most obvious step that Level goes through, the actual making the level in 3D. And we start this by having two inputs. We start working with concept, which gives us an environmental idea of what the place is going to be. When you're designing for CRPGs, the cities and the world are supposed to feel alive. So they have a lot of lore. You need to know who made them, what's the climate there even. So the level is going to structurally reflect all of this. It's important that we have this information before we start. And then we also work with narratives, so they give us some objectives of what is going to happen in the level. Maybe this is a quest about romance, maybe it's a romance quest, so we're going to tone down the pacing of the level so that maybe you have more opportunities to connect to your companions. This might be a level of a character presentation, so we're going to structure the level to build that presentation up so it matches with the character of the companion and how we want the player to perceive them. Once we have these two things, then we move on to the actual building of the level. Here, we're going to work really, really closely with 3D art because they are the experts in taking a vibe from a concept and then developing into an actual 3D space. So this, for example, is a prison that we have in one of our levels. And we're supposed to communicate a series of things. This is also a character presentation, so we need to take that into account. But for example, we need some lore from the company that has this prison to be explained. So we're going to create the spaces to make this possible. Working really closely with 3D art also gives us the challenge of this smooth communication between both sides. To bypass that, we've been using GridMap, which is a tool that Godot already has. It's basically a tile map. You have a preset of meshes, of 3D meshes, and then you can just rearrange them however you want. This helps to build modular levels very fast. We have adapted this, and we have granulated it, and now we have really, really small pieces. This is why my teammates say that I spend my days just playing with Lego, because we have all of these things. But the good thing about this is that we have taken this, expanded it, and now when the art team receives these pieces, they can substitute it with final art. This is really useful when you have to build many levels and you want to have a common base with 3D from which they can dress the level with. Another thing that we've been using for working with 3D especially is nested scenes. Throughout the development of a level, we probably reach to a point where the iteration is not going to be very significant. In that case, it's beneficial that the 3D art team can come in and start making changes. but we don't want to have any conflicts. So what we do is we create the little corner of 3D art, which is that beautification node, and it works wonderfully because they can be doing advances in this other scene. The changes that they do will be reflected in my level, and then when we merge everything, it's not going to register as a change. So we won't have any merge conflicts, and this is ideal. Another tricky step in our pipeline for level design is the actual event design and the scripting of these levels. We work really closely with narrative. They might give us a quest, like for example, the prison that I was talking about before. They might say, we have to infiltrate a prison and rescue this character that is going to be your companion. So we take this information and then we lower it to actual level logic. So if I'm working with a CRPG, I'm going to say that all problems should be solved in 3 or 4 ways. That would be a sweet spot. So I'm going to say maybe the player can steal a key from a guard and get in. Or maybe the player can charm the receptionist of the prison to get in as well. Or maybe they just want to kill everybody and get in by force. That's fine too. We take these steps and we lower them to this kind of workflow. And then we script them. And we script them in Loom as well. This has worked really, really well because sharing the same platform with another team makes it really easy to understand each other. They understand what we're doing in level, we understand what they're doing in narrative. It's not like we're scripting and it's a very foreign tool that they are not accustomed with. So this proves well. And then we have the end product, which is the experience that the player actually gets, the interaction with whatever logic behind it that there is. So why did we decide to use Loom for scripting? We started working with JavaScript, but we do have a diverse level team. We have somebody who is more art-oriented, somebody who is a bit more combat and gameplay-oriented, one of those guys who really likes spreadsheets and balancing, and then me, who is a bit more narrative-oriented. This is really good for making levels, because we have all of the 3 perspectives. But this means that we had different coding abilities. So we wanted something a bit easier to get into, like a visual scripting language. We started trying out things like Orchestrator, which is a plugin for Godot. But around the same time that we were trying these things out, Loom had been developed for narrative. And we just thought, I think Rick has too much free time. I think we can also expand this system to work for us. And also, if we have any problem, we can go annoy him directly, and we don't have to work with a third party. So we did this, and it has been working really, really well. We knew that we didn't want to have a full visual scripting language. We can't make functions, we can't make variables like arrays, but this is a conscious design decision so that we can have a lot of freedom, but also we can still keep it simple, and as I said, relate to the people in narrative who we work with very, very closely. This way, we ended up with a system that works in a way that a coder will develop a system, like for example, those are the files for the quest system, which Lucho right there developed, and that might be like 2 months of development. That's a lot of time. But then we'll sit down between the 2 departments, and we will find the way to translate this complex system into a series of Loom nodes that you can use easily. And the creation of Loom nodes is really, really fast. The system is put in place so that the code is fast to make. You're only referring to the actual system that's already created. And we can contain this system into, let's say, 5 nodes. We can close quests, we can open one, we can make some of the quests relate to each other, so if one opens, another one will open as well. So this has been allowing us to work between the 2 departments and understand the systems that we're working with really, really well. Last thing about the scene inheritance that I wanted to talk about at a building level is scene inheritance that we've been implementing since the beginning. This is the way that we structure all of our levels. You may have a lot of items and a lot of objects or of entities in your levels. And we wanted to make sure, because we're developing the technology at the same time that we're making content for the game, we wanted to make sure that iteration would be fast. So we just take all of the objects that we're going to have and we categorize them into different groups. As an example, we may have everything in a CRPG that we're working with is interactable. So we're going to make an interactable template that has the base of everything, maybe a mesh, an area of effect, whatever. And then we're going to make children of this template and make more templates. So we'll have, for example, a loot template. From this loot template, we can make a bunch of different types of loot templates. So it just goes on and on and on. But the good thing about this is that if at any point any of the logic of the interactable, of how it works, changes, we can just go to the parent template, and all of the changes made there will just cascade down to everything else, and we don't have to touch anything. The levels update automatically. So that's another thing that we've been using a lot. To wrap the presentation up, I thought it was important to mention that one of the strongest points that Godot has, it doesn't matter if you're a big team or a small team, for developing a game and developing tools specifically for your company, is the fact that there's a huge community backing you up. I remember I would talk about GridMap before. When I started working with GridMap, it didn't have all the functionality that I needed. So I decided to make an add-on. But I'm not a really good programmer, so I decided to go to the community and ask. And this was my first time actually engaging with an open source community of an engine. And I put this issue up, and the next day it had been labeled by somebody. Somebody had linked other relevant issues about it, and it had been registered into the information that you have here. So now my tool is actually deprecated because they implemented all of these things, and the next version of Godot, this is solved much better than I could have ever done. So I think that this is an important part of why choosing Godot to do something like this. And we came all the way here in part to thank you for having our backs so we can actually develop these things very fast and with this community backing us up. Thank you very much. If you have any questions, you can go ahead.
Yes, thank you very much. We still have some time for some questions. So if you have questions, raise your hands.
Hi, congratulations for the amazing work you've been doing so far. I have a question about deciding how to implement tools. I do that myself, of course, when I develop my own projects, but it's always a hard balance to decide how much time to spend on a tool and how much time it will be better just to stick to whatever we already have. But in this case, I can totally see the outcome that you got implementing Loom. But I don't know if you have a process to decide which kind of tool to implement, or if you have some sort of decision-making process.
When they stop asking for new features, probably is the time that you are there. They never stop asking new features, so at some point you need to focus on something else. I do not know, because actually our structure is a bit odd for a Godot project. We work in a very long term. As a company which is pretty big, again, it's not an indie. I mean, we grow, we have a lot of expense, and we need to work on our tool set that we can rely. And if we get add-ons, external add-ons, and that person stops developing it, it creates a problem. So it's better create our own things and think on the long term. We are not thinking about if this is going to be useful for this first game. We are thinking if this is going to be useful in the next 10 years. We don't try to make systems that will be bulletproof in 10 years. That's not my point, because that's bad. Don't do that. But in general, it pays off a lot, because the bigger the team, the bigger you are accelerating everything. The moment we did, for example, validating for Loom, Loom is used in logic, is used in narrative. We are using it now for AI. The moment you do validating, suddenly 10, 15 people are affected, and they are faster. So it's very difficult to say no to those improvements. Sometimes there are improvements that are very local, that will affect 1 or 2 people, and then you put them in the balance. But the thing is that it's very difficult to say no, because Godot is so fast. Validating and everything. The validator, it took 2 days, I think, to build. It's just so fast, it is ridiculous, the iteration time. So, yeah, the whole presentation is, you could be Samuel, do your own tools, it's so fast, it's ridiculous. Yeah, that's it.
Hi, thanks for the awesome presentation. I have 2 questions. You presented what seems like a very strict framework for like the folder and file structure where you have all the validations. And my question is like, when you decide how to change it and like how big the changes can be, because it seems very strict and strict things are hard to change. And more importantly, how long does it take for the GitHub pipeline to run and finish?
This guy knows this thing, yeah. Yeah, so in Epic Tailors, we have a very flat structure. So this file there is basically for anybody to change. So what happens is normally you get, like, for example, a newcomer arrives into Epic Tailors and they do something cool, and we are all looking at him as like, you still haven't met the pipeline, you'll see. And then it's like, yeah, I have this new thing, they just press, go to the pipeline. Why I cannot check in my changes? Well, you have 10 things wrong. Why I have that? Go one by one and you will learn. And at some point it's like, why I cannot put this file here? And if there is an easy answer to that, it's like, because this file doesn't go here, this goes here, and the name should be like that, the snake case, and so on. Then that's fine. But sometimes it's like, actually, that's a good point. Probably shouldn't be go here. Go to this file that I just copy pasted here and add the new metric to do it. You do it yourself. It's actually a file in the same repository, so it's self-contained. The moment you do the check-in, the pipeline goes. How the pipeline goes, it depends on how many people are trying to put things in. So when the week before a deadline or something, it becomes slower. I wouldn't say we did some improvements. I don't know, you guys help me here. It's like width, 8 minutes, 10 minutes probably. Sometimes can go faster, but we do lots of things like compile all the scripts, lint all scripts. It can take a long time sometimes. And this is basically all 3 computers that are in the home base of the parents of one of the developers. We just put it there with a message, please do not turn off. and so it's not an expensive setup. Anybody can do it.
It looks like you guys had a really big win with developing the Loom tooling. Is that something that you plan on releasing publicly available in the future?
The idea for the whole Starfinder thing is going to be, we want it to be very moddable. So we want a lot of mods. We want to open it. We still need to find out exactly how. But if you need to mod it, it means that you need to access it in order to do quests. So there will be some sort of access to it. Honestly, inside the team, we don't care much. It's more about the legal trouble than anything. We don't want somebody to just copy everything and publish it in Steam like we have a Starfinder, and suddenly I have to have a legal battle against some clones. As long as we can solve that, most likely this will be publicly available. The thing is that we don't code it to be generic. We code it for our needs that are pretty generic and probably can be used, but it's not in that situation. But I have to say, in the way we work, we do lots of add-ons. The add-on idea and structure is very useful, and I don't know how many we have, maybe 20, 30 add-ons to increase the tool set of Godot, and Loom is one. And then we have another area of code, which is systems for the game that can talk. But the add-ons are self-contained. So the idea is that, yes, you could use it, but probably will take some time.
Hello, my name is Ednigo Montoya. Prepare to answer another question about the build pipeline. The question is, you mentioned that your whole thing is built in Godot, but I'm not sure if you mentioned whether it's built in GDScript specifically, and that therefore the question extends into, is your whole pipeline, all the tests and everything written in GDScript then?
Everything. It's a GDScript that calls an OS execute Godot. So it's Godot calling Godot executables. We don't even use Bash or any other scripting. I work in Linux, I used to do all the scripting there, but at some point it's like, I want this self-contained, so somebody with Windows, somebody with Linux can do it. So Godot is actually the answer. You have the binary there. It solved like 10 problems in a row, just having everything by itself, self-contained.
Yeah, unfortunately, our time is now up. And we have to get out of here sometime soon. But thank you for the team of Epic Teller, Maria, Rick, and Felix for your presentation. And